Hey friends, welcome back to my channel, that is Learn Computer Science with Maanik Sharma. In this video, I am going to discuss some of the important facts regarding matrix in R programming. Initially, you will understand the theoretical aspect of matrix. Afterwards, you will see how a matrix can be actually created and manipulated in our environment. Let us first understand what is matrix. Matrix is a rectangular arrangement of data, normally numbers, in rows and columns. In a matrix, as we know, rows are the one that run horizontally and columns are the one that run vertically. In R programming, matrices are two-dimensional homogeneous data structures. Based on number of rows and columns, different type of matrix can be created. Some of the examples of matrices are shown here. These are 3 by 3, 3 by 1 and 1 by 3 matrices. Here 3 by 3 means there are 3 rows and 3 columns in the matrix. Likewise 3 by 1 represent that there are 3 rows and only 1 column. In our programming, to create a matrix, one has to use matrix function, which can be easily reproduce the memory representation for the matrix. In the R matrix, all the elements must share a common basic type. You have to pass how many numbers of row and how many number of columns you want to have in your matrix. One of the important points that need to be noted here is that by default matrices in R language are in column wise order. However, we can create a matrix in which the element can be stored in row wise. The basic syntax for creating a matrix in R is matrix bracket start data comma n row comma n call comma by row comma dim names bracket close. Here data is the input vector which becomes the data element of matrix. N row represent the number of rows, n call is number of columns, by row is a logical clue. If true, then the input vector elements are arranged by row. Dim name is the name assigned to the rows and columns. Further, it need to be noted that there is no need to mention all these parameters while creating a matrix. Let's understand how we can create different matrices by using matrix function and these parameters. In the first example, we have matrix 1 colon 6 comma n row is equal to 3 comma n call is equal to 2. In this example, we have taken only 3 parameters, that is data, n row and n call. Here 1 to 6 means that there are 6 different data elements starting from 1 up to 6. N row represent number of rows, n call represent number of columns. It means there are 3 rows and 2 columns in this matrix. As stated earlier, here data will be entered in the matrix in the column wise order. If you want to enter the data in matrix in row order, then we need to use by row parameter and the value of this parameter need to be set as true. For example, in second case m2 is equal to matrix bracket start 1 colon 6 comma n row is equal to 3 n call is equal to 2 by row is equal to true. You may also create a matrix by giving just 2 parameters. In the third example, a matrix M3 has been generated by simply giving the data and number of columns. R language will automatically fixes the number of rows as per the given parameters. Additionally, to set the names for the dimension of the matrix, if you want to set the name of columns and row, then you may use call names and row names for the same. You may observe that in the third example, after creation of matrix, the call name have been set as C1, C2, C3 and C4, and the names of the rows have been set as R1, R2, R3, R4 and R5 respectively. You may set the name for rows and columns as per the requirement. So for this, we need to use call names bracket start the name of the matrix bracket close equal to C function. So in C function you need to give the name of the columns that you want to set for your dimension. Likewise, for the rows we will use row names bracket start M3, that is the name of the matrix, bracket close equal to C function, and then we need to write the name for the rows. It need to be noted that the name of columns and the name of the rows has to be put in double quotes. Furthermore, if you are interested in finding the sum and means for rows and column of a matrix, you may use row sums, col sums, row means, col means for the same. It need to be noted that the S of sum and M of means are in capital letter. The general syntax for the same is, for sum of rows in a matrix we need to write row sums bracket start name of the matrix bracket close. To find the sum of column in matrix we need to write col sums bracket start name of matrix bracket close. Likewise, for the mean of rows in a matrix we need to write row means bracket start name of matrix bracket close. And finally, to compute the mean of columns in matrix we need to use col means bracket start name of the matrix and bracket close. Transpose is one of the important operation for the matrix. Transpose of a matrix is an operation in which we convert the rows of matrix in column and the column of the matrix in rows. The easiest way to transpose a matrix in R programming is to use T function. The general syntax for the same is MT is equal to T bracket start name of matrix bracket close. Here T function is used to find out the transpose of a matrix and the resultant will be stored in a matrix that is empty. You may use the name as per your convenience. The addition of two matrices can also be easily done using plus operator in R language. So let us consider that we have two 3x2 order matrices M1 and M2 that have been created using matrix function, that is M1 is equal to matrix bracket start 1 colon 6 comma n row is equal to 3 comma n col is equal to 2. Again we have M2 is equal to matrix bracket start 1 colon 6 comma n row is equal to 3 and number of column is equal to 2. So to add these matrices we simply need to write M3 is equal to M1 plus M2. Here the element of M1 and M2 will be added and the resultant will be stored in M3. Finally, if you want to remove the rows and columns from the matrix, same can also be done by using C function. Let us see how the matrix is actually created in R programming. In this practical session we will try to understand number 1, how to create a matrix in different ways, how to compute sum of rows and columns of a matrix, how to find mean value for rows and columns of a matrix, how to find transpose of a matrix, how to add two different matrices, finally how to remove rows and columns from a matrix. So let us start. So initially we will create a matrix, simple matrix, by writing M is equal to matrix. Here M is the name of the matrix. We have to give the data set, data values 1 to 6. It means there will be 6 different values, start from 1, 2, 3, 4, 5 and 6. Then we need to mention number of rows, say it is equal to 3, and then number of columns, say is equal to 2. Now let us see the output of this. So you can observe here that a matrix has been generated and there are 3 rows. This is the first row, this is second row, third row and 2 columns. So let us see again, say we will generate a matrix M2. Again we need to write matrix, then data value, say again we have given 1 to 6, then number of rows say is equal to 3, number of column equal to 2, and then by row equal to true. Now what does it mean? It means here the value will be inserted in a matrix by row. So let us first execute this, then we will able to see the difference. So let's run this. Now again you can observe that matrix has been generated, but in this case you can observe that the values has been inserted in the matrix by row. That is, the values are 1, 2 row wise, 1, 2, 3, 4, 5, 6. In the earlier matrix you can observe that the values has been inserted column wise. So 1, 2, 3 and then 4, 5 and 6. So if you want to generate a matrix in which you want to insert the values by row, then you need to mention by row is equal to true while writing the syntax of the matrix. Now what will happen if we do not give the number of rows? Say I am writing matrix, say 1 to 20. Now we have given 1 to 20, it means there will be 20 different values, and I am mentioning n call equal to say 4. That's it. Now in this matrix we have simply mentioned number of columns. We have not mentioned the number of rows. So what will happen? So nothing to worry. So the matrix will be generated and there will be 4 number of columns. How many columns? 1, 2, 3 and 4. So this is the beauty of the R programming, that it automatically computes the number of rows if we mention the number of columns and vice versa. So now if you want to give the name of dimension, so you can observe that here the name of dimensions are for the columns 1, 2, 3, 4 and for the rows 1, 2, 3, 4, 5. Now if we want to give the names for these dimensions for the columns and for the rows, how we can do this? So you need to mention call names. This is call names. So for which matrix? For M3. So again we need to use the C function, and here we can give the values. Say this is column 1, column 2, column 3 and column 4. Now similarly row names for matrix M3 equal to R1, R2, R3, R4 and R5, as there are 5 different rows. So now you can check the matrix. So let us run this. So here you can observe that the names for these dimensions have been updated. Now earlier there were column 1, column 2, 3, 4. Now we have given the suitable names, that is C1, C2, C3, C4. Likewise for the rows we have R1, R2, R3, R4 and R5. So based upon the requirements you can set the name for these rows and columns. Now another important aspect is how to compute the sum for rows and column. For that we need to use row sums. It need to be noted that row sums, in row sums S is capital. So row sums for M3. So you can check out the output. So row sums. So for row 1 the sum is 34, for row 2 38, row 3 42, row 4 46 and row 5 50. So you can check 1, 6, 7, 18 and then 34. So in this way you can also find out col sums for M3. Now again you can execute this, and now the sum of the columns has been mentioned: C1 15, C2 40, C3 65, C4 90. So likewise you can also measure the value of mean. So you can write like this: row means for M3. So this is the value of mean for row 1, for row 2, for row 3, row 4 and row 5. So in this way we are able to create a matrix, and we can find out the sum and average for the rows and the columns. So then if we have to find the transpose of a matrix, like suppose now we have, this is M3. So let us again check the output of M3. This is M3. Now we want to find out the transpose of a matrix. So this is very simple. So you need to simply write M4 equal to transpose. For transpose we need to use T, and then we need to write M3. So now I am writing M4 and then run. Now in this way, so you can observe that the transpose of the matrix M3 has been generated in M4. So here there are 4 columns and now 5 columns and 4 rows. So this is very simple in R programming. So last but not least, if we need to find out the sum of two matrices, how we can perform different operations on two matrices. Like suppose I am interested in finding the sum of two matrices. Say I am generating M1, M7 equal to say matrix 1 to 6. I am mentioning number of row is equal to 3, and then number of col equal to 2. In a similar way, M8 is equal to matrix again 1 to 6, number of row equal to 3, and number of column is equal to 2. M9 is equal to M7 plus M8. So we simply need to use the plus operator. Now M9 run. So you can observe that the addition of M7 and M8 has been processed and the resultant has been stored in the matrix M9. So finally, if you want to remove some columns from the matrix, column and row from the matrix. Like suppose let us consider M3 again, and you can observe that this is M3. Now I am writing M3 is equal to M3. Then we need to mention minus C1 comma minus C1. Now what will happen? Now M3. Now let us execute this. Now from this output you can observe that one row and one column, the first row and the first column has been removed from M3. So I hope that each and every aspect of this session will be clear to all of you. Please do like and share this video. For more update and technical insight of computer science, please subscribe this channel. Thank you.